I am with you always, even to the end of the world. Matthew 28:20. Greetings to you all in the name of the Lord Jesus Christ. Class 7 ICSE Physics, Unit 6, Part 2. In the last video, we have seen about what is sound, sources of sound, and also the sound produced by the larynx. And this class we are going to learn about the propagation of sound. So before we get into the lesson, let us learn some new words related to this topic. Propagation. 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 Compressed. 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 Refraction. 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 Vacuum. 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 Echoes. 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 Absorption. 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 Reflection. 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 Propagation. Compressed. Refraction. Vacuum. Echo. Absorption and reflection. In the last video, we have learned that sound is produced by vibration. Do you know how this vibration of a sound produced? To understand this, let us consider a drummer striking a drum. When a drummer strikes a drum, the drum skin vibrates. Is it so? So as the drum skin moves up, the air molecules around it get compressed, and as it moves down, the molecules spread out. The molecules close to the drum skin press upon the neighboring molecules and pass on the energy of the vibrations. Like this, waves of compression and rarefaction are passed on through the air molecules. However, the molecules do not travel. We all know that one. They just vibrate or move about their mean position. In the screen, you can see the compression and rarefaction. You cannot see the vibration of air molecules directly, but you can observe how such vibration set other things vibrating. This will help you understand how this vibration make the eardrum vibrate. So eardrum is nothing but the membrane inside the human ear. The vibrations of the eardrum are carried to the brain, which is how we hear sound. We all know that sound travels in the form of wave. So in physics, a wave is a disturbance, or we say it is a vibration that travels through a medium. Remember that it is a disturbance that travels and not the molecules of the medium. To understand this better, think of the waves among the cheering supporter of the football or cricket team. So the supporters do not leave the seats, they merely move up and down, but the wave travels around the stadium. I hope you would have all watched that one in the TV while watching that matches. So this kind of wave illustrates what is known as transverse waves. In a transverse wave, the vibration are perpendicular to the direction in which the wave travels. So another example of transverse waves are the ripples that spread over the surface of a pool of water when some stone or something is thrown into a pool. You can see it in the screen. And if a paper boat, plastic ball, or a piece of cork were placed on the surface of water, it would bob up and down because the water merely moves up and down. The disturbance spreads out at right angles to the movement of water. In the lower class, we have already learned about the longitudinal wave and also the transverse waves. So you can see both the waves in the picture. So compression and rarefaction are found in the longitudinal wave and crest and trough are seen in the transverse wave. Yes, in a transverse wave, the vibrations are perpendicular to the direction in which the wave travels, but in a longitudinal wave, waves in which the particles of the medium vibrate in the direction of propagation of the waves. Children, we all know that sound needs a medium to travel. Sound is a mechanical wave and needs a material medium like air, water, steel, etc. for its propagation. It cannot travel through vacuum just like the light. This can be demonstrated by the following experiment. Bell jar experiment. Here you can see a bell jar. An electric bell is suspended inside a large glass jar. Could you able to see that one? A rubber stopper closes the mouth of the jar. The two wires of the bell pass through the stopper. The air in the jar can be pumped out through an opening at the bottom of the jar. You can see a vacuum pump. Initially, the jar is filled with air. The bell is set ringing and its sound can be heard clearly from outside. But when we take out the air, that is when the air is gradually sucked out by the pump, the sound of the bell becomes fainter and finally cannot be heard at all, although the bell can be seen to be working. If air is then again allowed into the jar, the sound of the bell can be heard again. So far, we have been discussing the propagation of sound through air. However, air is not the only gaseous medium through which sound can travel. It can travel through all gases, and the speed of the sound in air is around 340 meters per second. In other gases, its speed is different. Children, you know that sound not only travels in gas, sound travels faster in liquid and solids than the air. This activity shows that sound travels in water, that is fill a tub with a beaker with the water. Shake a small bell inside the water. Make sure that the bell does not touch the mug, as this will reduce the vibration of the bell. Place your air close to the tub and surely you can hear the sound. This is how marine animals such as whales and dolphins can hear each other. So from this activity we can understand sound travels through liquid also. The next topic we are going to learn is absorption and reflection of sound. We know that light reflects. Not only light, sound too is reflected, is observed and transmitted by the material through which it passes. The intensity of sound, that is the loudness of the sound, decreases as one moves away from the sources, because the air through which it passes absorbs some of its energy. Is it so? If you move away from the phone, the loudness of my sound will decreases. Okay, because my sound is absorbed in the air. So some materials such as thermocol, cotton and wool are much better absorber of sound than air. Now let us learn about echoes. Echoes occur because sound is reflected by solid surfaces. Echo occur because sound is reflected by solid surfaces. Otherwise, we can say echoes or reflected sound. We can distinguish between a sound and its echo only if the echo reaches us about 1 by 15th of a second after we hear the sound. If it arrives sooner than that, we cannot distinguish it as another sound. That is why we do not hear echoes all the time, though there are many reflectors of sound all around us. Sonar. Sonar means sound navigation and ranging. An apparatus called sonar is used in ships to locate underwater objects and to find the depth of water. It sends out high frequency sound vibrations called ultrasonic vibration into the water. You can see in the picture. The time taken by the vibration to return is then used to calculate the distance of the reflecting surfaces. So we can find the depth of the sea by using an apparatus sonar. So here they detect the fishes using this device by sending the ultrasonic waves. Echoes in nature. Bats, they fly only in the night. Bat emit this ultrasonic vibration and judge the distance of a prey. Prey means food by the time it takes the echo to return. Dolphins, whales and seals use echoes to find their way around under the sea. Sound insulation. Sound insulation or soundproofing refers to cutting out unwanted sounds. Most often, a building is soundproofed either to eliminate the reflection of sound or to prevent the leakage of sound to and from the room or both. So, concert halls, auditoriums, theaters are soundproof to prevent the repeated reflection of sound from the walls, ceilings, and floor. Without a sound insulation, the reverberation or repeated reflection would make the sound indistinct. So the wall and ceilings are usually double layered and covered with materials that absorb sound, and the floor is carpeted. So you can see this in the picture. This also prevents sounds from entering and going out of the auditorium, theatre, etc. So sound recording studios seen in the picture are made completely free of echoes and insulated from external sounds. They are referred to as dead rooms. So echoes not only used to find the depth of the sea, it is also used in medical applications also. So image of a baby inside its mother's womb taken by using this ultrasonography. So this ultrasonic vibration are used by doctors to get a picture of internal organs. The reflection of the vibrations by the organs help to create images. So the technique is generally called ultrasonography, and in the case of the heart, however, the term echocardiography is used, ECG. So children, now let us recall the topics what we have learned today. Sound does not travel through a vacuum, it can travel through all gases. Second, sound travels as waves of compression and rarefaction. A wave is a disturbance that travels through a medium or spaces. Sound waves are longitudinal waves. When sound travels through a medium, Some of it is observed, some reflected, and the rest transmitted. The absorption of sound by the medium through which it passes causes its intensity to decrease slowly. Thank you.